Hello everyone, welcome to Module 4, your Capstone project. Already you've gone through 4 different courses teaching you about the introduction of data science, introduction of machine learning, and then bias and safety in these machine learning models. So now, with this Capstone project, you'll finally take a look at all of the skills that you've learned and acquired over the past few weeks, and finally apply it to our Capstone project. So without further ado, let's get started. My name is Rida Faraz. I'm a computer engineering and computer science major here at the University of Southern California, and I will be helping you go through your Capstone project for today. So what will we cover in today's video? We're going to go over a quick review of all of the key concepts that you've learned in the past few courses and which ones will apply to the project that you will be working on now. Then I will go ahead and introduce the Capstone project as well as the different tracks that you're allowed to take within them, and then finally give you a walkthrough of what the notebook will look like. So here's a review of what you guys have gone over in the past few lessons. Let's start with Module 0, Intro to Data Science. In this lesson, you learned about cleaning up data, how to make data visualizations, and then what a data distribution typically looks like. In Module 1, Intro to Machine Learning, you learned about the basics of training a machine learning model, as well as 2 different types of models that might be commonly used, decision trees and neural networks. In Module 2, Bias and Fairness, you guys went over fairness metrics as well as sampling bias. And then finally, in Safety and Robustness, you guys went over robustness testing, random smoothing, and different tactics for adversarial training. So if any of these concepts might be a little bit foggy to you, I would recommend going back and reviewing them quickly before getting into the final project, as all of these topics will be coming up. So for your first option, we have healthcare. In this one, you're going to be assuming the role of a hospital manager. You have a bunch of resources to distribute amongst the patients admitted into your hospital, but you're trying to figure out how you can best and most efficiently do this while still protecting the patients that are admitted into your hospital. So to do the resource allocation, you have come up with a different model. You have a bunch of records of the different patients admitted into the hospital, and you want to create a model that can actually predict what type of urgency their needs have. So whether they have been admitted into emergency care, urgent care, or just any elective hospital. So with this training data, you want to make this model, but there are a couple of things you have to consider before going ahead and training it. You want to make sure that all of your patients' privacy is cared for because you're dealing with very sensitive data and you don't want any leaks right there. On top of that, you also want to make sure that even though insurance is one of the variables that's taken into consideration when predicting the final admission type, you want to make sure that you're not discriminating against any patients with different financial backgrounds. For the second track that we have for you, we have the scholarship fund. You're in charge of a scholarship fund and you want to make sure that you're distributing the scholarship money to students that truly deserve it based on their merit. So once again, you have a record of all the different students as well as their performance in classes and outside of school. You want to basically create an algorithm that can predict whether they pass or fail a class, simply because you don't want to hand out the scholarship to someone that doesn't deserve it. So in order to do this, you have a bunch of data on students' performance and you're going to predict a pass or fail variable. You want to make some other important considerations, one which is gender. Gender is one of the variables that is used in the dataset, so you want to make sure that you're not discriminating against students based on their gender. Another consideration that you want to make is that all of the students that you're dealing with, you want to make an impartial decision. So you have to make sure that, once again, the student's privacy and data is secured. For our final track, we have the law track. So in this one, we're actually changing it up and implementing an existing algorithm. So the COMPAS algorithm has been used by judicial court systems in the past to determine something called a defendant's recidivism score. Recidivism is basically the likelihood of this defendant committing a crime again in the future or not committing one. So in the past, this COMPAS system has been known to be flawed, having both racial and gender bias when it comes to giving out these recidivism scores because of the data and discrimination that's implicit in the data set that was used to train these systems. So as someone that works at a judicial court system, your task is to go ahead and revise this COMPAS system to attempt to get better recidivism scores. So once again, the important considerations you have to keep in mind is you want to make sure that there is no racial bias implicit in your systems. And once again, since you're dealing with very sensitive information, you want to ensure that the defendant's data is kept secure and private. And so the main differences between every track is the data that lies behind that. But within each project, you will be going over essentially the same structure. So we want to go ahead and start off by testing out all of the different concepts that you've learned in the past few lessons. So let's start with data pre-processing. In the data pre-processing step, this is where you're going to be cleaning up the data set to prepare it for actually training your model. And then you want to implement the privacy as well in this segment. For the model training step, you will be implementing a basic neural network and training it to get a very, very accurate result as much as you can make it. Then you want to apply fairness metrics in this step as well, so all of the tactics that you've learned in lesson 2, bias and fairness. And then finally, for the safety evaluation, you will be applying the concepts that you learned in module 3 and figuring out how you can actually run an adversarial test on this model to test the robustness, and then applying any adversarial training tactics that you've learned as well. So now that I've introduced all of the tracks to you and the overall project structure, let's take a look at what the notebooks will actually look like. So just like we've done in the past, we're doing our notebook on Google Colab, and you will go through the different steps. Make sure to read every segment because there's a lot of important hints and details there for you. And then once again, these steps will help you lead through the final project. So let's get started. For our health track, we have the predicting hospital resource utilization. Once again, here's our introduction at the top. Over here, we've loaded in the data set for you. So some important things to know is these are all the different attributes that will be included in your data. And these are the different types of categories that they fall in, whether they're categorical type of data or numerical type of data. This will be important in your data pre-processing step. So once you see here, once you go in and load the notebook, here's what the data set looks like at a first glance. While this gives us a quick little overview at the top, we also want to go in and actually explore the data. So before you actually go ahead and explore and apply any of the cleaning steps, you want to make sure that before you begin manipulating the data, you truly understand its different categories. So we left some hints here for you to look over, including how you have to explore the number of categories within each categorical variable, and that will specifically come out when you go ahead and try to encode your variables. Because once again, you can't pass in categorical variables, something like gender, male or female, into the model directly. So you want to go ahead and ensure that you're accounting for this by encoding these variables, and that will come up in the data pre-processing step. But by exploring the number of categories within categorical variables, you can make better decisions. And then you also want to, in this step, create some sort of visualization to tell you more about the data. So this is a requirement on our end, but this will help you out by, once again, helping you learn more about the data that you're working with, and hopefully go ahead and help you train the model more efficiently. So for cleaning the data step, we have a little bit of it filled out for you. So any null values, or if there's any information missing within a patient's data attributes, we want to go ahead and drop that information before it becomes used in the final training model. But for the two things that we want you to take care of, we want you to encode categorical variables, just like I'd mentioned before. And then once again, also drop unnecessary columns. So any data that you think might not contribute to the final prediction, you should go ahead and drop. But you have to be very careful with this step because some of this data can be very useful without you actually having that human understanding or realizing the connection directly. So to go in further, in the encoding step, it gets a little bit complicated as some of the columns have far too many categories. So there are a lot of different tactics that exist to address something like this. For example, a lot of researchers, what they do is if you have an encoded variable with too many categories, they will usually combine the rarer conditions or the rarer categories into one other category. So that is one way to go about it, but I highly recommend you look into different methods that people use so that you can use the option that best fits the project. So we have you do the encoding step and dropping any values that are unnecessary, but once again, this project is what you make out of it, so you want to go ahead and do any data pre-processing that you think helps adjust the final model, and we highly recommend you do try other tactics. We also want to implement patient privacy before we go ahead and train the final data set. So since we're dealing with a lot of sensitive data, we need to ensure privacy is protected. And to do so, we already gave you guys one method suggestion, which is to simply drop personal identifiers. So in this data set specifically, name comes up a lot. And so we want to drop the name category when we're actually training the data because it's very safe to assume that a patient's name does not affect their final admission type. So another few features that we recommend that you might want to look at is the category the tactic of generalizing features, and then adding noise to the data. So generalizing features can basically be encompassed by this. So let's say you have a hospital. There's only one 100-year-old admitted into this hospital. So let's say we leave the age category in because it is a factor in determining priority and urgency. Well, it's very obvious if you have a 100-year-old who that patient is going to be, especially if you know more about the data set. So to actually address things like this, there's this other concept of generalizing features. So what we would do is instead of having the individual ages as a feature in your data set, you will basically separate them into something called bins. So let's say like ages 0 to 20 fall into one category, 20 to 40, and then so on. Once again, you want to do the research beforehand to determine the best and most optimal bins to ensure privacy while still ensuring the accuracy of your final model. But this step is a little bit up to your disclosure, but that's one way we recommend to generalize features and ensure privacy. The final method that we went over as well is adding noise to a data set. So with that, we have all of our data prepared and ensured that it's private. So now we can go on to training the model. So what we've provided for you right here is a simple implementation of something called a random forest. So from the sklearn library, we're going to implement a random forest classifier, which falls into, as we mentioned before, decision trees. And once you run this model, you'll find that it might not be as accurate as you would think so, because decision trees typically can't capture the complexities required of a data set such as this. So after you go through and actually implement the sklearn random classifier, you can determine how it's performing, but we want you to go ahead and then implement a neural network on your own. So we already gave you the import step, which is once again from the sklearn library, import a multilayer perceptron classifier. So this is what your basic neural network would look like, but we want you to build upon this, and we've left it very open-ended intentionally because when you're actually going ahead and doing research, it's really important to know how to navigate the documentation of all of these important Python frameworks and libraries out there. So we've linked the documentation. Go ahead and look through that and determine how you can actually go ahead and code your first neural network. Finally, we have our fairness metrics. So in the training step, you also want to make sure you're applying all of the different fairness metrics and techniques that we went over earlier. And so over here, we've given you like one tactic that's commonly used to predict fairness metrics, which is fairness criteria based on sensitive groups. So let's say we're looking at our gender category and we want to prevent gender bias. So determining based on whether it's a male or female patient, determining the accuracy of the model in these different categories will allow us to know how well our model performs on all categories. So let's say it performs better on male than female. Well, then that's an obvious case of some discrimination happening, which might be a result of the data set or the way that you train the model. So if you do find that there is an imbalance there, you want to go ahead and actually apply some of the tactics that we went over in Module 2. And then final step is going to be your safety measurements. So once again, we went over the concept of robustness testing. We gave you a very simple tactic to actually go ahead and try testing the safety and robustness of your system, and this method is called noise training. So by adding noise to some of the examples and testing your model on these new noisy examples, you can determine how susceptible your system is to damage from random and noisy data. So this is one good way of actually testing it out, but once again, we want you to go back to Module 3 and try some of the other tactics that you learned. And if you find that your model is not performing very well on the safety, we want you to go ahead and try two different things, which is going to either be go ahead and include adversarial examples in your training data set so that you can go ahead and predict them better, or number 2, random smoothing, which is involved in the actual gradient and training process. So with that, that is what your final notebook will look like. There's a very similar breakdown for the law track and the education track. The only main difference you'll find is the actual data. So a lot of the decisions you make will be based on the data set, but for the most part, you will be going over the exact same 3 components, which is training the model, pre-processing, and then the fairness and safety evaluation. So good luck on your projects and hope you guys enjoy the course.